Okay, in the previous video we scored this by eye, but there's also a scoring method that's built into the model itself. So let me go ahead and add a cell, and I'm going to take all model and call the score method, and I give it two things. So the first thing I give it is the independent variables for some test data. So that's going to be the iris test data, so input vars, and then the dependent variable values for the same test data. So iris test sub output vars. So it's just like we called the fit method and it adjusted this model to fit the data. Here it's making predictions on the output vars based on the input vars, and what it's really calculating is the correlation coefficient. So let's execute this, and what I get is a number between -1 and +1. So +1 means perfect correlation between the predicted values and the actual values. And what 0 means is no correlation at all between the predicted values and the actual values. And of course, if you're really messed up, you might get a negative correlation where your prediction is actually less likely to be correct than random chance. So it's a different kind of scoring than we were looking at when we looked at what was coming out of the model. And it's mainly useful for comparing the accuracy of different models. So you want a model that has a high degree of correlation. Now, we know that we were getting different results in our predictions on Setosa and Virginica than we were on Versicolor, but it's sort of hard to tease that out here. What you really want to do is start looking at separate models. So let's go ahead and do that. So what I'm going to do is I'm going to make a setosa classifier that just predicts whether something is a setosa or not. And I'm going to use the same iris test data, but here when I make a model, let's say setosa model is going to be a new linear regression. And then I'm going to fit the setosa model on iris test input vars. So I'm going to use all of the same input variables, independent variables, but for the output vars, I'm just going to use species, actually the species setosa variable. Okay, so there's my linear regression. And then if I want to calculate the accuracy, oh, I'm sorry, that should have been the training data. Let's try this again. So iris train on that, and then iris test, I'm going to use that to score. And I get a degree of correlation of 0.887, which is really high correlation, much higher than the 62% overall I was getting for all three models. And then let's do the same thing for one that we know is hard. So let's make a Versicolor model, which is going to be a new linear regression. And then we're going to fit the model on the training data, input vars, to predict iris train species Versicolor. And then let's show the score for that. And actually, go ahead and just paste that and change this to score on the test data and see what we get. So we only got 0.275 correlation on predicting Versicolor, which is pretty low. And then let's build one more model for doing Virginica. So this is going to be the Virginica model. And that's going to be on species Virginica. And we get 70% or 0.7 correlation coefficient. So both iris, the setosa classification, and also the Virginica classification are both over the overall accuracy of the model for predicting all three of the classifications. But we can use some knowledge of the domain here because we know that if it's not a setosa and it's not a Virginica, then it is a Versicolor. And so instead of building one model that predicts all three of the species, what we can do instead is use the setosa model here that has the highest accuracy to classify all the setosas. And then anything that isn't a setosa, then we can have a separate classifier for deciding whether that is a Virginica or a Versicolor. So let's see what kind of accuracy we get if we filter out all the setosas first and then remake the Versicolor model, but only on the iris training data that excludes the setosas. So let's go ahead and do that. I'm going to go ahead and make not setosa train, and that's going to be equal to iris train, where iris train sub species setosa is not equal to 1. So this is all the training data where it's not a setosa. And then on that data, I'm going to go ahead and build a model for Virginica not setosa. And then we're going to do Virginica not setosa is fit on not setosa train of input vars. And to predict not setosa train sub species Virginica. And then we're going to score that. So to score it, I want to do the same thing with the test set. So let me go ahead and do not setosa test. So not setosa test is the iris test data, excluding the setosas. And then to score this, I can score it on the test data. So that's going to be not setosa test, like so. Okay, so let's see what we end up with. Got an error. I misspelled Virginica probably. I misspelled species. species. Okay, and I ended up with 0.68 degree of correlation for my Virginica prediction that includes both Virginicas and versicolors. And if I do exactly the same thing here, but with versicolors, I'm going to use the same training set, so I don't need that. But then here, instead of Virginica, I'm going to do Versicolor. And so here's my Versicolor model. And then it's the same training data, except I'm trying to predict species Versicolor. And then I'm going to score that on the test data. And now here's the surprising thing. My accuracy, my degree of correlation between my predicted and my actual here should actually go up from about 0.275 all the way up to being the same as this 0.68. And it is. So interestingly, by removing the setosas, which were on one end of the scale, I end up with just the Virginicas on one side and the versicolors on the other with a little bit of overlap. And so my ability to classify versicolors goes up as well. So now I have three models. I can actually sort of link them together. Let's start with the training data. And I think I have iris train. So that's all my training data. And what I'm going to do is let's do the predicted from my setosa classifier and the predicted from my Virginica classifier, and add those two things as columns here. So setosa model dot predict iris test, so input vars. So that should be setosa predict is that. And then this is just an array, so I want to turn it into a data frame. So let's do pd.dataframe, and then this is going to return just one column, which is my setosa prediction. So columns equals setosa, actually predict setosa. Okay, and then let's look at our data frame. So it should just be one column, and it is. And then I'm going to join that with my iris test reset index drop true, like so. So that gives me the predict setosa along with the stuff from the training set. And then let's do Virginica predict is going to be equal to, actually I have my model here, was Virginica not setosa. So let's do pd.dataframe Virginica not setosa dot predict iris test input vars, and that's going to give me, actually I'm missing a closing paren here for the array. And then the columns here is going to be predict Virginica. And I would get the same results if I did predict setosa with Versicolor, not setosa, would give me the same accuracy but the opposite predictions. Okay, so that's going to give me the data frame. And then I want to join that as well. So let me do this. I'm going to join iris test and also join Virginica predict, which should have the same reset index as setosa predict. Okay, let's see if it worked. Okay, not quite. So let's see, columns is not defined. So I did that before. Okay, so I have predict setosa. And then on the other end here, I'm going to have to scroll a little bit. Yeah, I have predict Virginica and predict setosa. And actually, I want them on the same end. That's a trivial difference, but I think it's going to make my life easier. Or actually, yeah, let's do that. Okay, so predict setosa, predict Virginica, and then the actual data. And then if I wanted to combine these into one prediction, what I could do is say something like setosa predict dot apply, and then I want to get each row one at a time and run a function on it. And the way you do that is by using the axis equals 1. So here I give a function, and then I give axis equals 1, and basically that's going to feed each row into this function one at a time as a separate data frame. And then I can pull out whatever these values I want to use. So for my function, I could define a function like so, def classify x if x sub predict setosa is greater than or equal to 0.5, then return setosa. Else, if x sub predict Virginica is greater than or equal to 0.5, return Virginica. Else, return Versicolor. Okay, so this is going to return, pump that into classify. This is going to return a column with either setosa, Virginica, or Versicolor. And so I can say setosa predict sub predicted species is equal to that. And then let's look at it when it's done. Okay, so I have an error. Predict Virginica. So I have a key error. There's no predict Virginica column. And setosa predict predicted species. predict Virginica, predict setosa, predict Virginica. Let me go ahead and do a print here. Oh, I have to actually... Here, let's try this. Yeah, setosa predict has to get set to the result of the join for that to work. Okay. So here is my actual values, and at the end I have my classification. So we got Versicolor, setosa, Virginica, Versicolor, Versicolor, setosa, Versicolor, Virginica. This one's wrong. So I have a prediction of Virginica, but it's actually Versicolor. So that's one miss. And then Versicolor, Virginica, setosa, 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 Versicolor, Virginica, Versicolor, Versicolor, Virginica, setosa, Virginica, setosa, Virginica, 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 setosa, setosa. So all of these are right except for one. I only ended up with one miss in the whole set by splitting it into two separate classifiers and then using some logic to decide which classifier to trust first. And then just to sort of neaten this up a little bit so that it's easier to read, I'm going to sort values by predicted species. And then I can scroll down that list more easily. So yeah, so these are all setosas, and there's one in the species setosa column. And these are all versicolors, and these are all right as well. And then these are all Virginicas, except for this one. So one miss out of 30.